The main focus of our work this year was water purification, because as space becomes more commercialized and we start investigating the possibility of longer duration missions, water becomes the limiting factor, as it's very heavy, it occupies a large volume, and it's difficult in some cases to recycle.
So what our first part of our experiment consisted of was a water distillation system that we were trying to do something different as opposed to what the ISS is using now.
They employ a centrifuge which creates artificial gravity to separate the water from its materials and such. But having moving parts, it's liable to break down. So with our experiments, we're minimizing the amount of moving parts, and we hope to make it a backup system on the ISS.
And in our experiment, we tested out different water permeable membranes to act as a phase separator with our water purification system.
The second part of our experiment consisted of an NMR, or nuclear magnetic resonance spectrometer. It is capable of testing liquids and discerning their chemical makeup through their hydrogen contents. You put in the liquid with a small capillary tube or pipette through the in section of the NMR, and the NMR uses a magnet and radio frequency to test this liquid of its hydrogen content using a big magnet and radio frequency. We brought it up to the 0G plane because we wanted to test changes in its position and orientation in regards to the magnetic field to see if it would properly function or what outcomes would result of a change in orientation and position. So, yes.